Okay, example 3 says solve for an angle that's between 0 degrees and 360 degrees. So once again, our answer is in degrees. And we need to round to the nearest hundredth. We're only going to round to the nearest hundredth if we're using our calculator. If we find the value on our table of exact values, then we don't need to round. We need to use our algebra skills here to get the trig ratio by itself. So I'm going to go ahead and subtract 6 cosine theta. So I'm going to get 2 cosine theta minus 10 equals negative 12. Add 10 to both sides. I'm going to get negative 2. Divide by 2. I'm going to get cosine of theta is equal to negative 1. So if I go over to my chart, I'm going to check and I go to the cosine row. And so when does cosine equal negative 1? That happens at pi. Okay, so if that happens at pi, we need to think about this. This is a special case. So if we think about the unit circle, and I always like to think back to our quadrant or our axes angles, our quadrantal angles. So when our angle lies on an axis, those tend to be special. We've said that all along. Those you kind of have to think about differently. So if I look at this, if my angle is 0, that point on my circle is 1, 0. That means the cosine of 0 is 1 and the sine of 0 is 0. If I'm up here at pi over 2, this is the point 0, 1. So that means my cosine of pi over 2 is 0. My sine of pi over 2 is 1. Go over here to pi. This is the point negative 1, 0. My cosine of pi is negative 1. The sine of pi is 0. And then finally down here at 3 pi over 2. This is 0, negative 1. So the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is negative 1. So in this case, our angle that we're solving for is this angle here, which is pi. That is the only place from 0 to 360 that cosine is equal to negative 1, only at pi. So in this instance, we will only have 2 answers. So my solution, in this case, we'll only have 1 answer. I'm sorry about that. So my solution here, when is cosine equal to negative 1? My solution is cosine is equal to negative 1 at pi. Let's say, for example, we had wanted to know when is sine of theta equal to 0? Well, now if we look at this, when is sine equal to 0? Sine's equal to 0 at 0, and it's also equal to 0 at pi. So here we would have 2 solutions. This is just kind of a side example. We would have 2 solutions. We would would say sine is equal to 0 at 0 and at pi. So really it comes into play when we're talking about 1 and negative 1 on those axes angles, those angles that lie on an axis. So those tend to be the ones that trip kids up a little bit because they're trying to find, well, 2 different solutions. But in this case, we only have 1 solution. The only time that cosine is equal to negative 1 is at an angle of pi. Okay, so now we're going to come down here. We're going to do example 4. One thing I want to notice is my range is now in radians. So my answer is going to be in radians. So let's bring down, let me see. I'll just put this here in case we need it. Oops. Trying to get it to shrink. All right, there we go. So first thing we want to do is to get the trig ratio by itself. So I'm going to add 9 to both sides. So 7 tan x is equal to 7. divide by 7, I'm going to be getting tan x is equal to 1. So that's what I'm trying to solve. I'm going to check over on my chart and see if this is an exact value. Tan does equal to 1 in a first quadrant angle of pi over 4. So that means my reference angle is going to be pi over 4. So this is an exact value. So I'm going to use a chart. And I'm using the chart to find my reference angle. So my reference angle here is going to be pi over 4. I now have to look, and I'm trying to find, it's a positive trig ratio, so I need to ask myself, when is tan positive? Tan is positive in quadrant 1 and quadrant 3. So that means my solutions are going to lie in quadrant 1 and quadrant 3. So now I can go ahead and find my solutions. My solution will be in radians, so my quadrant 1 angle will just be the reference angle, which is pi over 4. So when tan of pi over 4 is equal to 1, my quadrant 3 solution is going to be pi plus pi over 4, or 5 pi over 4. So at pi over 4 and 5 pi over 4, the tangent will be equal to 1. So now we are at example 5. Once again, I'm going to look and see what range my angle is given in, and my range is given in radians. So my solutions, or my answers to this, will be in radians. Round to the nearest 100 if necessary. So if we're working with our calculator, we will have to round. This is set up as a proportion. We have two ratios, or two fractions, equal to each other. So in order to solve this, we can go ahead and cross multiply. So I'm just going to use my algebra skills. I'm going to get 7 tan of x plus 3 is equal to 40. I'm going to get the trig ratio by itself, subtract 3, and I'm going to get 37, and divide by 7. I'm going to get the tan of x is equal to 37 over 7. So this is not in my exact values table. So I'm going to have to go ahead and use my calculator. So I need to be super careful here because now I'm working in radians. I need my answer to be in radians, so I need to switch my calculator back to radians. So you're going to need to remember that we're in radians here. So I'm going to go back. I'm going to check that my mode, I had switched it to degrees. I'm now going to switch back to radians. And now I'm going to find my reference angle by plugging this into my calculator. So I'm going to go ahead and plug tan inverse 37 over 7. This is positive already, so I don't need to worry about plugging in the positive value. I end up getting 1.38 radians. So I have my reference angle. So now I can kind of do my solutions. The things that I know. I have my reference angle is equal to 1.38. I need to think, when is tangent positive? Tangent is positive in quadrant 1 and quadrant 3. So my solutions will lie in quadrant 1 and quadrant 3. I can go ahead and come up with my solutions now. My quadrant 1 solution is just going to be the reference angle, so it's going to be 1.38 radians. My quadrant 3 solution is going to be 2 pi minus 1.38. So I go ahead and just do that on my calculator. 2 times pi minus 1.38. 2 times pi minus 1.38 gets me 4.9. So 4.9 radians. So those are my two solutions.